Okay, so for college algebra here, as I mentioned yesterday, we're looking at some more logarithms. Okay, this is solving with logarithms. And so there's going to be kind of three types of problems we're going to look at in this section. The first one is dealing with the exponents and solving with exponents. We have another type of problem where we're dealing with the logarithms. Okay. And then we'll do a couple more where there's kind of logs on both sides, and we'll talk about that. So, kind of three types of problems that we're going to look at today. So, this first one, we've seen problems like this before, but on those types of problems, it was like 7 to the x equals 49. And I could get them both in the same power. When I do this, I can't get 7 and 20 to the same power. It just doesn't work. And so, what I have to do is I'm going to turn to logarithms here. And we can add 7 to both sides. We can divide both sides by 30. As long as whatever you do to one side, you do to the other, you can square both sides. Same thing applies to logarithms. So I'm going to take the log or natural log. Both of them are fine here. I'm going to use natural log. But you can either do a common logarithm like we talked about yesterday or a natural log. Those are the most common you're going to use because, again, those are kind of the most readily available on most any scientific calculator. Okay. So just like I said, we're going to take the natural log of both sides. Now, the reason I like to do that, or the reason we do that, is because remember, a power becomes a product. So this power now that we were trying to solve for can now multiply times that, like so. And now, since it's a product, all I have to do is divide. Remember, natural log of 7 is just a number. So I can just divide that over to the other side. And so I end up with natural log of 20 divided by natural log of 7. Okay. Again, I can just type that in my calculator. We talked about that yesterday. Just divide by that. And usually round 2 or 3 places. I think this one said to round 2 decimal places. So 1.54. So again, if I were to plug that back in, 7 raised to that power, that would give me about 20. Again, we a little bit off because we rounded. Okay. So using logarithms to solve exponents. All right. Let's look at another one here. So on this one, I have this 5 here. You can notice it's a little bit different than that one. So if there's something there that doesn't involve the exponent, I'm just going to divide it to the other side. So if I just divide both sides by 5, now it's 1.8x is equal to 4. Now, again, I can either do natural log or log. This time I'm going to use log, so common logarithm. So I'm going to take the log of both sides. All right. Now that leaves me, I have a power again. I can bring that down out front. So I have x log 1.8 equals log 4. And then all I have to do is divide that over again. So I end up with log 4 divided by log 1.8. And again, I can just type that in my calculator. Again, most scientific calculators have that programmed on there. And I get about 2.36 if I round the nearest 2 decimal places. Okay. So using logarithms, again, if there's something that doesn't involve the power, you can add, you can subtract, you can divide it over, and then take the log of both sides, and then you can just solve from there. Again, that bringing that power down is the important part because it goes from a power to a product, which is obviously a lot easier to work with. All right, so that's one type of problem. Another type of problem is when you have a logarithm, okay? And what we're going to do is basically change it back to an exponent to deal with it, okay? So here we can see we have 7 times natural log of x equals 28. So again, this doesn't involve the natural log, so I'm just going to divide it over, just like we did up there with the 5. So if I just divide that over to the other side, I have natural log of x equals 4. So now I'm going to change this back to an exponent. Remember, I can use the definition. I always call it that looping. So down here, remember, that's a base of e. So it's e raised to the 4th equals x. E raised to the 4th equals x. So I change it back to an exponent. And again, I can just type that in. E to the 4th power, I can type that in my calculator. I get 54.6 is equal to x. Okay, so changing it back to an exponent can help me on that type of problem. All right. Same thing on the next one. You can see we have a logarithm here again. Again, what I'm going to do is I'm going to get rid of this 3 because the 3 doesn't deal with anything with the logarithm. So I'm going to do that first. I'm going to subtract that to the other side. And that leaves me 2. Now, kind of like the last one, now I'm going to loop it. So I'm going to do 6 raised to the 2nd power equals the 2x plus 4. And now I can solve that because as we know, 6 squared is just 36. Subtract over the 4 to get 32. Divide both sides by 2. And x has to equal 16. Okay, so that's another type of problem. So the first type of problem, we're taking log of both sides to solve for it. This one, we're getting the log by itself, and then we're looping it to put it back to an exponent, and then solving it from there. So that's the second type of problem. All right. Third type of problem in this section looks like this. Now you'll notice there's still a logarithm in the problem, but now there's a log in everything. Where notice here, this didn't have a logarithm and these didn't have logarithms. These all have the logarithm with them. So what we're going to do is we're going to condense each side. Remember how we expanded and condensed in that one section? I'm going to push these back together. Remember, a plus sign means you're going to multiply these together. If it was a minus, we would divide. I'm going to leave this one alone because it's already a single logarithm. And then over here, I'm going to multiply. So that if I multiply that, that'd give me 4x plus 40. So I'm just distributing that 4 to both of them. Okay, so 4 times that gives me 4x plus 40. Now it's a single logarithm. It's very important. You have to have it to be a single logarithm. But once you do that, you can basically cancel off the logs. Okay, so it's just x plus 25 is equal to 4x plus 40. And then again, we can just solve that equation. So this one, if we just finish this out, I would subtract over the x to get 3x. And then subtract the 40 to get negative 15. Divide by that 3, and we get x equals negative 5. Okay, so again, important though, when you're solving these, it has to be a single logarithm on each side. You have to condense each side before you cancel it off. You cannot just cancel it off at this point. It has to be just a single cancel off. Boom, boom. Okay, so it has to be a single logarithm to do that. All right, let's look at another one of those. So flip it over here. Here's another one like that. You'll notice it's like that last one we did. Everything has a logarithm on it. Now you'll notice in order to put them all together and cancel them off, they do have to have the same base. I don't think they'd ever give you a problem where they're not the same base, but that's important to point out. They do have to have the same base in order to like condense them and cancel them off. All right, so here we have minus. So remember, minus means divide. So I have x plus 6 divided by x plus 2. So I use that condensing to get it to be a single logarithm. Now that it's a single logarithm, I can cancel off those logarithms. So I end up with x plus 6 over x plus 2 equals x. Okay, now I can solve this. Now to do this, it's going to be a little bit more because we're going to have to go like this, and I'm going to cross multiply. So I'm going to take 1 times x plus 6, and I'm going to take x times x plus 2. And that'll get rid of the fraction. So that's called cross multiplication. It's like having when you have a proportion, when the two fractions equal each other, you can just cross multiply. All right, now I can solve this. I'm going to distribute the x. I get x squared plus 2x. Distribute the 1 is just x plus 6. Now, because I have a squared term, I'm going to get it set equal to 0. So I'm going to subtract everything over to that left side. If I have 2x, take away x, that just leaves me x. Subtract the 6 over from nothing is negative 6. So x squared plus x minus 6 equals 0. From this point, you have to solve a quadratic. Remember, to solve a quadratic, you have the choice of, most of the time, 2 choices, either quadratic formula or factoring. Okay, let's factor this one. Most of them should be factorable at this point. So I need things that multiply to negative 6 and add to positive 1. So that would be positive 3 and negative 2. And then what makes each one of these equal 0? Well, this would be negative 3, so x could equal negative 3 or positive 2. So there's 2 things there that will make that one true. So again, same as the other side, except for now it took a little bit more to solve it because we ended up with a squared term. But the concept is the same. Get it to be a single logarithm on both sides. Once it's a single logarithm, cancel that off, and then you just have to solve with what's left. Okay. So that's the third type of problem that you'll see. All right. So those are the three big types of problems in here. And then, as always, as you go through this book, there's always a couple word problems in there. And so what they have you do on this is using those financial formulas. So we saw those financial formulas in the previous sections. So we're going to use this one right here in this problem. Okay. Remember, E is that value, kind of like pi, it stands for a number. We have our principal, our rate, and our time. So they tell us that we're starting with $4,000. So that's going to be our P value. E, we know our interest rate. Now it's 8%. Don't forget to change that. So that would be 0.08. We don't know the time because it says how long will it take to get to 10,000. So I know in the end, I want it to equal 10,000. I don't know how long it's going to be. So you can see here when they set up this problem, you end up with the exponent as your variable. And so we're going to solve this one like we did on those very first problems. All right, this is going to look a lot like that second one. So what I'm going to do is this 4,000 doesn't involve the power. So I'm going to divide that over first. So if I take 10,000 divided by 4,000, again, I did that earlier, that gave me 2.5. So I have 2.5 equals e to the 0.08 times t. Now, again, you can use natural log or log. I'm going to use natural log because I have an e in the problem. So I'm going to take the natural log of both sides. Again, you can do common logarithm. That's fine. But a lot of times it works out better if you use natural log because we already have an e in the problem. All right, again, the reason I want to do that, I took the natural log of both sides, is now I can bring this whole power down out front. So I have natural log of 2.5 equals 0.08t times the natural log of e. Now, here's where it's helpful to have the natural log. Then remember, the base is e. So you're saying e to what power is e? So natural log of e is just 1. And since I'm multiplying by it, I don't really need it. This is just 1. So the only thing I have to do is I have 0.08t equals this. I'm just going to divide by 0.08. And that will get me what t equals. So again, I just have to type that in my calculator, natural log of 2.5 divided by 0.08, and I got 11.5. So it'd take about 11 and a half years to have $4,000 get to $10,000 at 8% interest. Okay, so that's kind of an application of where you would use logarithms to solve in a problem like this. And again, we've seen that formula before. That's just a way to solve it. Before we had all the values over here and we found this. Now they're telling us this, and we can either solve for interest or time. A lot of times it's solving for time, but it could be solving for interest too, because that's also in the exponent. Okay, so again, three types of problems here. This is where you take the log or natural log of both sides. This is where you get the logarithm by itself and then loop it. And then this one, you condense each side and then cancel off the logarithms. So three types of problems here, all involving solving with logarithms in a problem. But that's section 4.5.